Hey folks, Mr. Dell here. We are looking at a area and perimeter of composite figure problems in a kind of an application format here. So this is a problem that's coming from CPM's. So this is CPM Math, Integrated Math 2, and this is section 8.2.2, number 846. It says at the right is a scale drawing of a floor plan for Zynga's dollhouse. The actual dimensions of the dollhouse are 5 times the measurements provided in the floor plan at the right. So this is just a scale drawing, right? The actual measurements are 5 times what we see in this scale drawing. But let's go one step at a time. A says use the measurements provided in the diagram to calculate the area and perimeter of our floor plan. So we're going to start off by just using this diagram and calculate the area and the perimeter of the scale drawing, right? So how do we do that? First of all, let's start with perimeter. Perimeter is just all the distance around, right? Perimeter is add all the sides. So I've just got to make sure I have all the measurements of the sides, and I just add them all up. So I have, looks like I'm missing this one here and that one there. So I need to figure out those two, and then I would have all the sides. So how do we do that? Let's start with this one. To get this one, we know that this is 8 and this is 4, and the whole thing is 20. So I could go 20 minus 4 plus 8, which 4 plus 8 is 12. So that tells me that this would be 8, right? Because now I can see 8 plus 4 plus 8 would be that whole 20, right? So we know that's going to be 8 centimeters right there. And then this one here would be, let's see, so a little trickier. So I know, let's see, I know this whole thing is 12, and right here is 9. So that would tell me that, let's see if I draw this in here, because this is 3, so this would be 6. So from here to here is 6. So if that part is 6 and this is 12 over here, then this has to be 6. All right, did you follow that? Hopefully you did. If not, hit pause, rewind, and see that again. Okay, so I've got my sides now. Let me erase all my marks here and just rewrite my side lengths. So I know this is 6 and this is 8. So my perimeter now, I just add them all up, right? 12 plus 20 plus 9 plus 8. I'm just working my way around. Plus 3 plus 4 plus 6 plus 8, right? Add all of my sides up. And that should give me 70. So I have 70 centimeters for my perimeter. Okay. So my area, I can just cut this thing up into, looks like 3 rectangles, right? I mean, I can go ahead and just cut it up like I had earlier. So I can cut it up here and here. And I know that that's 6 and that's 6. So this tells me that I have, let's see, so area, I'm going to have this large rectangle here, which is going to be an 8 by 12. So my first one is an 8 by 12. So I would take 8 times 12 to find that first one. Then I'm going to add that to this little one in the middle here, and that's going to be a 4 by 6. So 4 times 6 is the area of that one. And then this one here, let's go this way, is an 8 by 9. So I'm going to add that to 8 times 9. When I do all the math there, I should end up with 192 centimeters squared. So there's my area and perimeter of my scale drawing. So now it says, part B says, draw a similar figure on your paper, label the sides with the actual measurements, right? So we knew that it was 5 times the amount. So let's see if I can do that real quick here. So I'm going to just do another scale drawing. Another drawing, but this time I'll label the side lengths 5 times. So really, this is not 20, it's really 100 centimeters. I multiply by 5. That's 45 centimeters. This is going to be 5 times that is 40. This one is 15, because that was 3. This one's 20. We know this is 6 times 5 is 30. 8 times 5, again, 40. And then 5 times 12 is 60. So there's my actual sides. So once it wants this time once more perimeter and area of the actual sides, right? So we have the perimeter is add all the sides one more time, right? 100 plus 45 plus 40 plus 15 plus 20 plus 30 plus 40 plus 60. So if I add all those up, my perimeter would be 350 centimeters. And so that's the actual size of the dollhouse. That's the actual perimeter. The area, in this case, one more time, we could cut it up as I did before. That from there to there was 6, so it's 30, right? That from there to there is also 30. So my area would be 60 by 40. So I'd go 60 times 40, and then I'm going to add that to the 20 by 30. And then I'm going to add that here to the 40 by 45. So if I add all those up, my area should be, when I do my math here, 4,800 centimeters squared. Okay, so that's the actual dollhouse. So it goes on, it says, what is the ratio? So ratio, remember, is just a fraction, A over B. It's just written as a fraction, A or B, whatever I'm comparing here. Ratio of perimeters. So I would do, let's say the perimeter of the small was 70. So the ratio of perimeters would be 70 over 350. And if I simplify that ratio, I can actually divide top and bottom by, I believe by 70 actually. 70 goes into 70 once, 70 goes into 350 5 times. So my ratio is 1/5, right? So really, what does that tell me? That tells me that my, what do you notice is the ratio of perimeters equals the scale factor, right? So it's a 1:5 or 5:1. We'll write it that way because really it's 5:1 is the ratio. It's the scale factor, right? So we multiplied each side by 5. So that makes sense that the perimeters would also be 5 times the amount, right? And then what is the ratio of the two figures of the areas? So let's go with the areas. And I put my area of 192 over 4,800. If I simplify that, I believe actually you can divide top and bottom by 192 and you get 1/25. So once again, my ratio for is a 25:1 area a factor, and 25 comes from 5 squared. So 5 squared, which makes sense because area is always square units. So the area is 5 squared the amount of the actual scale factor. Okay. All right, there we go.